name is Muhammad Farhan bin Abdul Nasir. My metric number is 194189. I am from umbrella.co, group 40.
Hello, I'm Tasnim Ashikin bin Tamizi, 192178. I'm from umbrella.co, group 14.
Hi, my name is Alena Jah binti Zakaria. My metric number is 191851. I'm from umbrella.co, group 14.
Feed use is bituminous coal from eastern Canada. The feed rated to the plant is at 5 ton coal per day. Now for the overall process, the 5 ton coal per day feed to the overall methanol plant and then produce 1.22 ton methanol per day. By feeding 5 ton coal per day, our plant methanol produce 1.22 ton methanol per day, which is the purity is 65.27%. The process description: from the coal that feed to the water slurry tank, and the coal will mix up with the water and then move to gasifier, and then the air separation unit will separate the air and produce O2, and then feed to the gasifier, and then the coal will burn in complete combustion, produce a lot of CO here, and then produce a lot of molecule. And next, the water quench is to separate the slag produced in the gasifier from the syngas. Next, the scrub, and then onto the scrubber. The scrubber will separate the particulate, or also known as solid, which is unconverted carbon that will separate here from the syngas. And then next, the hydrolysis part, where the feed contains syngas will convert a lot will convert 95% of carbon COS, carbonic cyanide, and then convert it into hydrogen sulfide. Alright, next, the absorption used to remove all the acid gas components such as hydrogen sulfide, which is H2S, from the syngas. Let's see. Next, the synthesis is to convert the carbon dioxide and carbon monoxide with the presence of hydrogen gas to produce methanol and water. Next, the separator is used to separate the impurities from the syngas, the impurity from the methanol solution. Next, the distillation column is used to separate the liquidify the methanol from the H2O. That's it for the process description. Hello, my name is Muhammad Farhan. So this is the stream one, which is containing coal, fed to the local water grinding, while the stream two containing water that will fed to the local water grinding, and then it will produce the combination of coal and water. So the ratio stream two here to the stream one is 0.5, 0.54. Next, the air separation unit, which is the stream flow containing air fed to the air separation unit, and then uh, it will separate O2 from the air, which is 94%, while the other 6% will flow in stream 5 in air residue. The stream C will fed to the entrance flow gasifier. Next, the entrance flow gasifier, which is the stream 3 from water slurry tank that flow to the entrance flow gasifier, while the stream 6 that containing O2 come from air separation unit. And then the outlet to the stream 7 is the syngas that produce, which contains solid and slag. And then this stream is stream 7 that flow to the water quench. The assumption that we make is all ash in the coal turned to slag, while the solid, which is only contain unconverted carbon, which is the conversion of carbon from the feed to the outlet, is 0.5%. Next, water quench. The water quench. Stream 7 is the feed to the water quench that comes from entrant flow gasifier, and then this quench will separate the slag in stream 8, and then the other outlet, which is the syngas that doesn't have slag, in stream 9, that will flow to the water scrubber. The assumption that we make is all slag completely removed from the gas, which means that efficiency quench is equal to 1. This stream that containing water is supposed to reduce the temperature from 300 degrees Celsius in the water quench from the initial temperature of the syngas in 1400 degrees Celsius, which will be calculated in energy balance. Next, in water scrubber, the fat is in stream 9 from water quench transferred to the water scrubber that to separate the unconverted C, which is in the solid, in which is the unconverted solid in stream 8 to stream 10, that will flow to the waste tank, and the other syngas that doesn't have unconverted solid, which is in stream 11, which is will flow to the hydrolysis units. Next, in acid gas removal, the feed to the hydrolysis unit, which is stream 11, from water scrubber will flow to the hydrolysis unit, which has efficiency of 95%, temperature of equal to 200 degrees Celsius, and pressure about 0.1 to 1.26 bar. Then the catalyst that I use is activated alumina-based catalyst, which is flow in and then flow out at the bottom stream, which is the instruction that we make is the catalyst does not reacted in the reaction at hydrolysis unit. In this hydrolysis unit, the COS, which is carbonyl cyanide, converted about have a conventional conversion equal to 0.95, which is produce hydrogen sulfide and CO2. Then the stream 12 is the outlet of the hydrolysis unit. Okay, so the next process unit is the absorption unit, which is used to separate the hydrogen sulfide, which is have the efficiency of 0.99, and then the stream 13 have a physical solvent, which is DEPG, which is used to physically absorb the hydrogen sulfide, and then we will flow together in stream 14. And then the other component, which is CO to CH4, will flow in the stream 15, and then containing a little bits hydrogen sulfide and carbonyl sulfide. Okay, next is the synthesis.
I will explain about synthesis unit. The synthesis unit feed comes from absorption unit of acid gas removal. The equation for synthesis unit is here. CO plus 2H2 producing methanol, and CO2 plus 3H2 producing methanol and water. The unfractional conversion of CO is 0.77, conversion of CO2 0.89, unfractional conversion of H2 is 0.24. Okay, as we can see here, from this feed, we produce about 17.23 kilomole methanol per day. Next, the feed from synthesis will go to LLE, which is the liquid-liquid extractor. Liquid-liquid extractor, the main function of this unit is to separate methanol and water in liquid form and separate all the other impurities in vapor form using a solvent. The temperature for this unit is 72 degrees Celsius and the pressure is 7.5 bar. Okay, the feed from absorption, the feed from synthesis. The feed is from synthesis. 17.23 kilomole methanol per day and 31.58 kilomole water per day. We use pentane as the solvent and we use basis 100 kilogram. When the solvent come into the unit, it will absorb all the impurities including CO, H2, CH4, CO2, N2, AR, H2S and COS. All of all of the impurities absorbed will go out to this stream through this stream as a vapor, and methanol and water will go out as a liquid in here and will go to the next unit. Unit is the distillation column. The distillation column is to purify the methanol and separate the methanol with water. The pressure for this unit system is 0.9653 bar and the temperature is 81%. Our goal is to get 99% of methanol and 1% of H2O. From the feed from LLE, we have 537 kilogram methanol per day and 568 kilogram H2O per day. These are in liquid form. Next, we will separate the methanol and water, and the result is we got 1102.325173 kilogram methanol per day, which is pure methanol here, and we have 0.219 kilomole H2O per day. Recommendations are adding more than one methanol synthesis will produce more methanol, thus increasing more income. Next, by adding Selexol unit in acid gas removal to produce elemental sulfur that can be sold as a product to generate more income, thus our profit will increase. We can conclude that we are able to produce 1.22 ton methanol per day from 5 ton of coal per day. Our profit is RM2435760.49 per 300 days of operation.